we're going to be computing derivatives that involve trig functions. And in other videos, you've seen that we have derivatives for all 6 trig functions. Those need to be memorized, and I'm going to list them here for you now. So the derivative of sine of x is cosine x. And the derivative of cosine x is negative sine of x. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent of x turns out to be secant squared of x. Secant squared of x means secant of x times secant of x. Those are the 3 main trig functions, and then we also know the derivatives for the other trig functions. The derivative of secant of x is secant of x times tangent of x. And I'm not going to fit that in very well, am I? I didn't leave enough space for myself. The derivative of cosecant of x, oops, I spelled that one wrong. The derivative of cosecant of x is negative cosecant of x, cotangent of x. And the derivative of cotangent of x is negative cosecant squared of x. One thing I want you to notice is all of the functions that start with co have negative derivatives. So the derivative of cosine is negative sine. The derivative of cosecant is negative cosecant of x times cotangent of x. And the derivative of cotangent is negative cosecant squared of x. You have to have these derivatives memorized. You have to have these derivatives memorized. They will even be on your test with the derivatives listed and 6 blanks. This has to be memorized because in order to do all of the problems that involve trig functions, you need to know these derivatives. Okay, and like I said, we've shown in other videos where these derivatives came from. What we really want to do in this video is practice finding the derivatives of functions that have these bad boys in them. So let's jump into the examples. So we'll start with the function y equals 3 over x plus 6 sine of x. Before we start this problem, I'm going to rewrite 3 over x as 3x to the negative 1 plus 6 sine of x. And I'm doing that because I'm going to use my power rule to find the derivative of 3 over x. Now let's go right to the derivative. So we know that you just do these derivatives in pieces because we have a sum rule. So the first derivative that I'm going to compute is 3 to the negative 1. And that's going to be negative 3x to the negative 2. Remember that negative 1 minus 1 is negative 2. This second piece here is just a constant multiple of sine of x. So the constant multiple is just going to stay there, and then I'm just going to multiply it by the derivative of sine of x, which I've memorized is cosine of x. The derivative of sine is positive, cosine of x. And then finally, I'll just clean this thing up for my final answer. This is negative 3 over x squared. We're going to write it in the same form that they presented it to us, plus 6 cosine x. This thing's an x. And let's highlight it to make it official. Highlighting doesn't look as awesome on this dark mode, but you get the point. So you do these pieces separately. One of them uses the power rule to get negative 3 over x squared, and the other one just uses the derivative of sine of x, which is cosine of x. Easy peasy, right? Well, let's move on and see if it stays easy. Okay, so we're going to jump in with this function y equals x squared times the sine of x. And as soon as I say the word times, I realize this is actually a product. It's x squared times sine of x. There are 2 functions of x multiplied together. And when that happens, I have to use the product rule. So I'm going to jump into product rule mode. And remember, when we do the product rule, we get organized by assigning one of these functions to be u. I'll make x squared equal u. And the other one to be v. So I'll make sine of x v. And then here's how I get organized, right? I write down u equals x squared, and u prime then is 2x, and v equals sine of x, and then v prime is the derivative of sine of x, which you've memorized as cosine of x. And now to finish this problem off, we simply write out the product rule, which for us is v times u prime plus u times v prime. So my derivative is going to be v sine of x times u prime 2x, and I usually write that like this, 2x sine of x. Then there's a big plus sign in that product rule formula. And then it's going to be u times v prime. So that's x squared cosine of x. Now there's no simplifying I can do or anything like that, so this bad boy is done. The derivative of x squared times sine of x is 2x times sine of x plus x squared times cosine of x. And remember, we recognized that we had a product and we had to apply the product rule on this one. Here is another product, and this one's a little more complicated. Notice that I have the secant of x times this other function, which is a sum, sine of x plus cosine of x. This is still a product, right? There's still two functions of x multiplied together. So I have to follow the product rule. I'm going to put it over there to emphasize that point. So let's assign u and v. I'll make the secant of x equal u, and I'll make this sum here equal v. U equals the secant of x. You've memorized that the derivative of secant of x is secant of x, tangent of x. And then if v is sine of x plus cosine of x, we just do that derivative by doing the derivatives of each of the pieces. So the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. So that becomes cosine of x minus sine of x. Now we have our four pieces. We're ready to write out the derivative using the product rule. Our derivative is going to be v times u prime. Now this looks nasty, but go ahead and write it out. And then a big plus sign, and I'm not going to fit it on the screen, so I'll go underneath here. And then it's u times v prime. So that's going to be secant of x times cosine x minus sine of x. Now, we're done. We did the product rule, but we can clean this thing up a little bit. What I'm going to do is distribute the secant x tangent x to each of those, and then I'll also distribute the secant x to these. And we'll see if we can clean this up a little bit. Okay, so when you multiply secant x tangent x by sine of x, remember tangent is sine of x over cosine x, and secant's 1 over cosine x. So that's just going to be sine of x over cosine x times sine of x over cosine x, which is actually just tangent squared x. Here's a tangent right here, and then this sine of x times this secant of x makes another tangent. So we have sine squared of x. Then there's a plus sign. And when you multiply secant of x, which is 1 over cosine, times cosine, you get 1. And so all we're left with is tangent x for that one. And then we're going to distribute here secant of x times cosine of x. That's just plus 1, and minus, when you do sine times secant of x, you get another tangent of x. And so this is just tangent squared x plus tangent x plus 1 minus tangent x. These two tangent x's are going to cancel. And I have tangent squared x plus 1. And if you've kept up on your Pythagorean identity, cosine squared x plus sine squared x equals 1, you'll remember that a version of that is tangent squared x plus 1 equals secant squared x. So the derivative of this thing that we started with is actually just secant squared x. Now what that tells me is that this thing is probably tangent x. But we wanted to practice the product rule on this, so that's the deal. This one's a mess, but it's doable. You just have to stick with the process, write neatly, neater than I am, and follow the process and you'll get there. And then don't forget to have your little handy-dandy gold thing next to you so that you can look up your trig identities if you don't have those memorized, because they're all on that packet. Okay, let's go to another example. So here's a function, cosine of x over 1 plus sine of x. And you guessed it, this is a quotient. We are going to have to use a quotient rule on this thing. And the way the quotient rule works is we assign u to the top function, the numerator, and we assign v to the denominator, and then we get organized. So u equals cosine x. That means the derivative of cosine x is negative sine of x, and you know that because you have it memorized. V is, whoa baby, that's a highlighter. Let's do the pen. V is 1 plus sine of x, and the derivative of v is going to be 0, because the derivative of 1 is 0, plus cosine of x. So I'm just going to put cosine of x. And then we have to write all this out in the quotient rule. So y prime is going to be, remember, quotient starts with v. So we're going to put 1 plus sine of x times u prime, which is negative sine of x. I'm just going to write the negative sine of x in front, but this is v times u prime. Minus u times v prime. So cosine of x times cosine of x, which is cosine squared of x, divided by v squared. So 1 plus sine of x, quantity squared. Okay, so we've done the quotient rule. Let's just clean this up a little bit. See if I can squeeze any of this in here. So we're going to distribute the negative sign, and that's going to give us negative sine of x minus sine squared of x minus cosine squared of x. Oh goodness, let's not do that. It just doesn't fit. So I'm going to cancel that, and let's just write it underneath. Sorry about that. Okay, so we have negative sine of x when I distribute, minus sine squared of x, minus cosine squared of x, over 1 plus sine of x, quantity squared. Now, I happen to recognize something in this expression. Negative sine squared of x minus cosine squared of x is the same as negative 1 times sine squared x plus cosine squared x. And we know that as the Pythagorean identity. So that's a negative 1 times a 1. So this whole thing here is just minus 1. And I'm going to factor out that negative 1 and write this as negative 1 times 1 plus sine of x over 1 plus sine of x squared. And I'm going to have to head up the side here, but this just simplifies. One of these cancels, and I end up with negative 1 over 1 plus sine of x for the final derivative. And so this is my derivative. If you made it to here, you did the calculus. The rest of this is just simplifying a trig expression. And it's a nasty trig expression, I get that, but we're going to keep practicing it because you should be able to get to this one. Again, keep your identity sheet handy, the gold packet, if you need to look up any of these things. Okay, one more example and then this video is done. Okay, so this function is y equals 7 over cosine x plus 5 over tangent x. And many students have the urge to treat these as quotients. But rather than do that, let's make our lives easier. Two slides ago, we already went right into the derivative without simplifying it. It made the problem longer. I'm going to start by simplifying this bad boy, and it'll make our lives easier. So I'm just going to rewrite these functions. 7 over cosine x happens to be the same as 7 times the secant of x, right? Because secant's just 1 over cosine. And 5 over the tangent x happens to just be 5 cotangent x. If you write this using those reciprocal functions, then the derivatives are just slam dunks because you already have those memorized. So I recommend that you work these problems this way. The derivative y prime of 7 secant of x is just going to be 7 times the derivative of secant x, which you have memorized as secant x tangent x. And the derivative of 5 cotangent x is just the 5 times the derivative of cotangent x. There's a negative sign in that derivative, so I'm actually going to erase this plus sign and turn it into a minus. So this is going to be negative 5, and that's going to be cosecant squared. Let's spell that correctly. Cosecant squared of x. And that's the derivative. So we make this little switcheroo here first, and then the derivatives are much easier. Okay, so we're going to practice some of these. We're going to spend a few days on this, mainly because my guess is you're a little rusty with your trig identities and just simplifying trigonometric expressions in general. I'll give you a few problems to work on, give them a go, and then we'll talk about solutions next time we see each other. Take care.